Okay, so today we are talking about visual ratios and showing how ratios can be described using visuals. So in this activator, Marissa wrote that the ratio 5/8 describes both images. Austin disagrees. Who is correct? Well, let's count. Let's see. In the circle, we have 1, 2, 3, 4, 5, 6, 7, 8 slices, and we have 1, 2, 3, 4, 5 slices that are shaded in. So that can be represented as 5/8 or 5 parts out of 8 total parts, pieces, which would be the total. Let's count the shirts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, well, I don't see 13 in here. Well, let's count the blue shirts. 1, 2, 3, 4, 5, 6, 7, 8. Okay, maybe that's where they're talking about 8. And 5, I guess, represents the white. 1, 2, 3, 4, 5. Okay, so if I was to look at this 5/8 for the t-shirts, and we're talking about ratios, I know that I could write 5 white t-shirts to 8 blue t-shirts. And I know if I had 5/8 over here by this circle that looks like a pizza, I could say there are 5 blue pieces out of 8 total pieces. So both are correct. You can look at the shirt scenario as 5 white shirts to 8 blue shirts. In this case, we are comparing white shirts to blue shirts. In the circle scenario, we see that there are 8 total pieces and 5 blue shaded pieces. It can be read as 5/8, or 5 pieces out of 8 total pieces. So they're both correct. They're just using 5/8 in a different way. 5/8 for the circle represents a fraction. 5/8 over here represents a ratio. We could write that as well. So you could say that, what I said above, or you could say 5/8 for the t-shirts represents ratios, and 5/8 for the circle represents comparing pieces out of a total, which is used for fractions. Okay. Today, we're going to use visuals to talk about ratios. Move to the next screen after you're done being amazed by the circles. Tell me at least 3 things you know about this image. I see 6. Let's do a tab. I see 6 red circles. I see 4 blue circles. What else? I also see 10 total circles. Those are 3 things I see. Anything else you see, you can add to that. Students often notice there are 6 red circles, 4 blue circles, or 10 total circles. We just said that. A ratio can be thought of as comparing the quantities of two or more items. Let's compare the red circles to the blue circles. Select the ratio of red circles to blue circles. Since they say the word red first, what number goes with red? 6 goes with red. There are 6 red. And since they say red first, we're going to say 6. So first one is correct and the second one is correct since they put 6 first. Then they say compare red circles to blue circles. So then they say blue. So the number that goes for blue goes second. And the number that goes for blue is 4. So I want to see 4 second. So this one would be the correct answer. Explain your thinking. Since the ratio asks us to compare red to blue circles, we have to look at the number that represents red first. The number 6 goes with red. And the number 4 is represented by blue. I picked the ratio 6 colon 4, 6 or 6 to 4, because they say red first and blue second. Since the ratio asks us to compare red to blue circles, we have to look at the number that represents red first. The number 6 goes with red, and the number 4 is represented by blue. I picked the ratio 6 to 4, or 6 to 4, because they say red first and blue second. A classmate saw the ratio of circles as 6 to 10. What two quantities is your classmate comparing? The two quantities, because I'm turning my question around. I think I spelled that wrong. Quantities. Quantities my classmate is referring to is 6 red circles to 10 total circles. There are a total of 10 circles. Perfect purple paint. On the next few screens, you'll be making purple paint by mixing just the right blend of blue paint and red paint. When you're ready, move to the next screen. Purple paint requires an exact mixture of blue and red. The ratio of blue paint to red paint is 2 to 5. Drag the blue and red points to make 7 cups of purple paint. When done, select a response below. This makes sense and I will explain, or I'm confused and I'll enter my question. So they say 2 first and they say 5 second. They say blue first and they say red second. So it looks like I want to put 2 blue and 5 red. All right, so 2 blue, I'm going to make 2 blue. And then over here on the right side, I'm going to drag the red and create 5 bars of red paint. 1, 2, 3, 4, 5. That makes the perfect purple paint. Okay. Does this make sense? Yes, this makes sense because I used 2 bars of blue paint because they said blue first in the sentence. Then I used 5 red bars because they said red second in the sentence. When this mixture was mixed together, it created the perfect purple paint. Using the same ratio of 2 blue cups to every 5 red cups, fill the jar with 21 cups of purple paint by correctly mixing blue and red paint. Okay, so let's read this again. Using the same ratio of 2 blue to every 5 red cups, fill the jar with 21 cups of purple paint. So I want to get to 21, but I have to mix blue and red at the same proportion. So I have 2 blue, 1, 2, 3, 4, 5 red. Okay. I need 2 more blue. So let's see. Oh, okay. So then that would bring it to 4 because double 2 is 4. And then let's double the 5 to 10. So we want to go 10 more up. So if we're, if we are at, we're going to go 1, 2, 3, 4, 5. There we go. Okay, let's add another 2. So we're going to bring this up to 6. And then we're going to go up 5 for the red. 1, 2, 3, 4, 5. Yes, this makes sense because did I double or did I triple my recipe? I did this 3 times, 3 rounds. So because I tripled my recipe, right click, recipe. I tripled my recipe and used up. So if we started at 2, triple 2 is 6. 2 times 3 is 6. 6 bars or 6 cups, let's say that. 6 cups of the blue paint. And if we had to use 5 cups of the red, 5 tripled or 5 times 3 is 15. And 15 cups of the red paint. Yes, this makes sense because I tripled my recipe and used up 6 cups of the blue paint and 15 cups of the red paint. 6 plus 15 equals 21. Purple paint requires an exact mixture of blue and red. The ratio of blue paint to red paint is 2 to 5. You can use a tape diagram to help you see how the amounts of the ingredients compare to one another and the total amount. To show how the ingredients compare, represent each cup of paint with a rectangle. Does this ratio of blue paint to red paint represent a part to part or a part to whole ratio? So they said 2 goes with blue. So I need 2 blue and I need 5 red. 1, 2, 3, 4, 5. Okay, so I've dragged out the amount of paint I need as a tape diagram. Does the ratio of blue paint to red paint represent a part to part or part to whole? Oh, so they're saying if we read this as 2, so there's 3 ways. We could write it as 2 to 5 or 2:5, or you could write it like, and it looks like a fraction, 2/5. And if we were looking at it like a fraction, even though ratios are not always fractions, but fractions can be ratios, 2 to 5 doesn't represent 5 total pieces. How many total pieces do you see? This would be represented as a part to part ratio because 5 is not the total amount needed to create the perfect purple paint. You actually need 7 total pieces. I don't see 7 in the ratio above. Let's fix this. There are 3 ways to write a ratio. So those are the 3 ways. We have 2 to 5 in the word form, or we've got 2:5, and then we have it in fraction form. So we're looking at it as a fraction form, 2 to 5. And this would be represented as a part-to-part ratio because 5 is not the total amount needed to create the perfect purple paint. You actually need 7 total pieces. And I don't, see 7 in the ratio above. Purple paint requires same thing, 2 to 5. Complete the table diagram to show the same information as the tape diagram. Cups of blue paint, I need 2. Cups of red paint, I need 5. And total, 7. That's my total. Okay, Marissa needs 35 cups of purple paint to paint a wall. How much of each color would be needed to make a total of 35 cups of perfect purple paint? Okay, so I'm going to put 35 here because they're saying total, right? To make the purple, we want 35 total cups. Based on the previous slide, we put 7 in that column because 2 plus 5 is 7. So we have to think of a number. These two numbers, when added together, will make 35. But we can't just pick anything we want to pick. We have to make it work. So I'm actually going to draw over this real quick to show you. Okay, if I zoom in, okay, basically, if I multiply everything from here, so I have to do 7 times something to get 35. I'm going to do the same thing with 5, and I'm going to do the same thing with 2, because whatever I do to one side, I got to do to the other side. Everybody has to be multiplied by the same number to get to this bottom row. So 7 times 5 equals 35, right? So that means I have to do 5 times 5, which is 25. And I also have to do 2 times 5, which is 10. So what happens when you add 10 plus 25? You get 35. So that's why that works. So that had to be 10, and that had to be 25, because 10 plus 25 is 35. But do you see how we had to multiply every cell by the same number to make it true? And this was our clue, this 7 and 35. This helped me figure out I need to multiply 7 times something to get to 35, and that number was 5. So then if I do 7 times 5 here, I have to do 5 times 5. I have to do 2 times 5. And then if you notice, it all works out perfectly because 10 plus 25 is 35. The school band brought cheese and pepperoni pizzas to the ratio represented in the tape diagram for their end of year party. Based on the ratio, how many pepperoni pizzas did they buy if they bought 6 cheese pizzas? Explain how you know. So I'm going to let you guys solve this problem. If you notice, it says cups of cheese. This should be cheese pizzas, okay? Not cups, cheese pizzas. And then cups of pepperoni should really be pepperoni pizzas. So if I look here, that would be 1 pepperoni pizza, and this would be 1, 2, 3. This would be 3 cheese pizzas. So go ahead and work on these. And show me that you learned something from what we just went over. And if you're not sure, write it out. Based on the ratio, how many pepperoni pizzas did they buy if they bought 6 cheese pizzas? So it looks like you might have to do something. I think you can drag these. So, oh yeah, you can. So you can drag these If they bought 6 cheese pizzas, remember, it's got to go be the same. So if there's 3, let's drag this to 6. I doubled it. I think I need one more. 1, 2, 3, 4, 5, 6. If I doubled the original 3 cheese pizzas, what would happen if I doubled the amount of pepperoni pizzas? Think about that.